Hello everyone. Welcome to another session with Code with your friend. In our last session, we tried to submit a solution to Leetcode and it failed uh, very weirdly. So what happened is for one specific input, the program did not run. The program is very simple. It's a two-sum problem. It did not run for one specific test case. It, however, ran for the remaining test case, and even it ran for the test case when run locally. That's I think an even problematic scenario. So I won't spend too much time on that today because I don't think like if it's working fine on my machine, then probably it should be fine. But anyway, I think we can go into that, navigate that solution, but that's not the purpose of my sessions. My purpose of this session is to learn more about hash map in C. So the best way to learn is learning from others. So what I would do today is basically look at some of the other solutions which have been submitted because we were able to submit at least one C solution, which is not very optimal. So we can look at some of the optimal solutions and see how they have implemented and probably learn from that. So let's do that. So our implementation was like very bad. So we would go with, let's say, a mid-level implementation. So what this guy did is you have to sum the nums, then size and the target and the return size, initialize an array. What we do here is, okay, so we do the same thing, but instead they just used pointer indexing instead of the array indexing. I don't think if that would matter too much. Um, Nothing very different. It's not actually a hash map solution. So let's go a little bit higher than that. Okay, this is, I think, quite a big solution, and I see some of the hash usage here. What is this guy doing? So what this guy is doing is creating an array, size of integer, max, min. Okay, this is, I think, an interesting step. Let's read through it. So idx is update nums I, check target minus num j, and value idx of nums I plus 1, so that matching nums j can know the idx right away. I didn't get anything from that. So let's say we have the num size. So we are iterating through the entire array. This is just finding max and min. So we find the max value and the min value. And we create an hash array table with the size of that. And now I think we iterate again through it. And each time we get target minus num size minus min idx. If idx is greater than or equal to size, idx is less than 0, then continue. I need to run this just to understand. I mean, I'm sure like this must be some cool algorithm going on behind this, but I'm too dumb to understand all this. Just trust me, bear with me, and hopefully, if you also have like a similar kind of intellect, you might benefit from here. So let's do that. We go here. We'll go to the C folder and open VS Code. It had opened into the second screen. Bring it here. So let's try to understand, learn from other solutions in Leetcode. That's, I think, a very good way to learn, right? Like you should always learn from others. So what we would do is we'll create maybe another solution here, do some C, and then we go back here and find out this. So the returned array, I think this is command that's not used. So idx would be nums I check target minus numj value, which is idx of num, so then matching nums here can know the idx right away. I need also the runner main function, so just let's try to understand it from this guy. So I can just call this guy, do some internal and remove the return size. I totally think this is useless. Here already is returning a constant, so why pass that value? Okay, so now let's put some print statement. He or she already had a bunch of print statements. I'm pretty sure that the person who submitted this also needed to verify the algo. It's very complicated, but seems like faster than ours, so good job. Now let's compile this. GCC minus O 1 underscore some 2 1 underscore. Oh my god. We haven't included any header stuff. Strlib also. So here it says hash size 9, minimum 2. Don't bother about the max, okay. And then you have check IDX 5. So then again, we're iterating over the same array. And we are getting target minus numSci and minimum check IDX is IDX if it's greater than equal to 0, or if it's less than 0, then we continue hash IDX is result 0, hash IDX minus 1, result 1 is equal to I, break. I need more print statements. I can't still understand. So I'll print. I think I understand from till this because we are passing 2, 7, 8, and 10. The max is 10 and the minimum is 2. The target number minus nums I minus min, and then we are keeping an IDX for that. So okay, if IDX is greater than equal to size or less than equal to, and this size is basically the hash size, and IDX is less than 0, then continue. Otherwise we find it from if hash index is not 0, then we find the result, and otherwise we calculate IDX is equal to nums I minus min, and we do update IDX there, and then we do hash IDX I plus 1. And then we return result. In the first iteration we have IDX is 5. Let's see what, I guess probably it's better if we print all the numbers, right? So target is, I think it's fine, it's a constant. So numSci be useful, and then num size %t, minimum is %t, and check idx is num size minimum idx. Okay, and idx is greater than equal to size, idx is less than 0, then continue the hash idx. Okay, now let's try to run it. So now we have num size 2 and minimum is 2, which would mean idx would be 5. And at this time, idx, we won't. idx is greater than equal to size. No, so if it's not, so this one would be here. Then we update idx as 0, num size minus min. So we lost 10 minutes just understanding this solution. This is like so cryptic, man. What does this mean? Do you think is this so hard to understand? Probably I'm not just concentrating enough. Let's just remove these distractions. So we have a hash table, we have like a result array, and then we have a max min. Max min initially both is initialized to the first number, then we update that. So till this part I'm clear. What I'm not understanding is like why we are creating a hash map of minimum and maximum size. Is it okay? Oh my god, it's. I think I am getting it. Oh man. But I don't think it's a very optimal solution. So what this guy is trying to do is basically just have a index-based hash map. So yeah, that's why he mentioned IDX there. So it's an index-based hash map, and every time we try to find the index, because that's why I think the hash map will have the minimum number and the maximum number. Those many entries could possibly be there. So we can try to map some of those elements there. For example, in this first case, I mean, we have slots for hash size of 9. So we have 9 slots, and then when we get the first number at 2, we try to see if it's present there or not. If it's not, we also do minus min. Essentially, we want to find the if that ID is present in that way. So basically, we just map that number to that hash table in some IDX. And okay, so let's try to visualize this, right? I hope like most of you have understood, but let's for my sake. So we have this. Let's put this under comment. So we have this two max and min numbers. So you have 2 and 10. Now we have created slots in 9 slots in the hash map because 10 minus 2, 8. So what the slots we have, it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 slots. Initially the hash map is empty. Then we encounter the first in number, which is 2. Target is 9, nums I is 2, minimum is also 2. So our target now becomes 5. We check if it exists in 5, it doesn't. So now IDX becomes 0 and we update this IDX, which means now we update 2 into this particular number. So and this hash IDX just becomes like I plus 0, which means I is 0 for that. So it will just contain the index basically for that number. And I mean, we don't bother, like whatever it is, we are just checking if it's present or not. So we would basically just mark this with some value. So we are marking with 1. we can always mark with 1. Even I think then the algo should work fine. Uh, then what we are doing next time when we are coming in, so let's say for this particular case, when 7 comes in, then only we are finding a match. So for 7, we are doing 7. The target is 9, and this is 7, so it's 2. And then minimum is also 2. So if we subtract that, the IDX becomes 0. Now we check all of these things, and IDX is 0. IDX 0, however, is not empty. So we find what is the number. And we also keep the ID through that. So yeah, actually we use it initially here. So we get the ID from there, we do a -1, and then we put it back. The only reason we added +1 to it is because we wanted to do this kind of check if it's present or not. It's basically just marking that value there. So it's doing a hash map, but it's using a lot of storage. Imagine what would happen if you have like a very large min and max, right? So you would waste that storage. So not a very good solution, in my opinion, but very complex to understand. And probably maybe the implementation. The approach is not that difficult, but implementation. So now we'll go to straight to the best solution. Uh, what is this solution? What is this solution doing? Uh, is this just checking for the number of elements in the array if it's case 3, if second number is 3? Oh my god. Does this actually... So, I mean, this guy basically just did a trial and error of all possible array sizes. So it basically shows like what are the test cases Leetcode has. So let's just take this is an interesting example. It's obviously like a shitty solution, but I mean, no one should ever try to approach like a Leetcode problem. And this, I mean, you don't learn anything. You probably will have like a one solution which is accepted like better than everyone else. But I mean, you're like deceiving yourself if you're doing that. But through that, if it does just the intention is to understand like the Leetcode what they're testing a solution with, then this is I think the best solution. And I think probably that would be the intention. No one would create a solution with that. Who knows? So yeah, let's just help the solution with removing return size for that. Oh my god, I love this. So the initialized solution is 0 and 1, and doesn't have a case for like less than 3 or something. It's only starts from case 3, then case 4, um, case. Why does it assume always if return will be 0 and 1? Because the problem statement says that there would be always some value returned. So interesting. So there are a lot of test cases with 4 elements. I think this is our test case. No, it's not our test case. We have 4 elements, and then the nums3 is 0, nums3. This this is insane. This is insane. So let's modify this, and what I want to do is we can. So ours, here I got the idea. Our solution didn't get accepted by Leetcode, right? Our solution was this, using a hash map, which did not get accepted by Leetcode, uh, for one particular value, which is if the array is a 2-element array, and then if we have only these 2 elements and the 2 elements are same, and the 2 elements are 3, only in that case it's not accepting. I don't know what's happening. There must be something happening. It should be a deterministic program, but something is messing up. Anyway, and if we have the target result as 6, and we do a compilation here let's say for 1_1. So we are printing it right? But I think if we submit the same solution in Leetcode, it's throwing us like, no, you are giving me 0 and 0. The solution that you're giving me is the same. But the same is not happening if we are doing, let's say, for 4 and 3. I mean, if two values are same, but not, let's say, 3, then we are getting it. So even in this case, we are getting proper answers. So it should be fine. So what I'm planning to do is basically using that other solution, the hard-coded if-else, like switch case-based solution, and generate all possible test results for Leetcode, right? Because I'm sure like this solution would still work. Like if I think if it's showing as accepted, which means it'll still work, right? Oh, I think I need to put the function wrappers there. So, so it basically works and it beats everyone. The low memory and uh, yeah. So which means like it covers all the test cases and that's wonderful. So what we can do is basically we can print all those test cases, run against those test cases locally, and then we can move on. Then we won't have like any burden on our chest like our solution did not get accepted by Leetcode and it's probably wrong. So let's do that. The way we can do it is I guess like the one problem that is here is it is doing a very specific checks. Um, for example, if there are 4 elements in it, then we have like nums, only one number check is there. So this might create a problem because this is actually sparse information, right? So in few cases, probably we can like reverse engineer back. For example, in this particular case, if nums 3 is 3, but we don't know the target for that case because this guy is not using the target at all. Uh, so, and it will fail if I, for example, in if nums2 is 3, then it assumes like the result will be 0 and 2. It might not be that case, right? So, which shows like Leetcode has like 2 3 element solution. So we can't do basically what we wanted to do. That's a bummer. Um, it shows like a snippets of it. I hope this guy put on like more work and what we can do here is the number of submissions that took to get this out, right? Like we can probably extract this information. Um, let's do something quick here. In our solution, what we had submitted, right? Can we, not this, let's say, yeah, this one. Let's bring back the solution here. I'm just so hung up like why it's not working. And what we can do here is only run it if the input size is more than 3, right? We can do the same thing that this guy is doing. Just um, initialize with this, right? Initialize with this and don't do anything. If num's size is less than 3, then just return array. Or in our case, I think we are calling it indices. So let's just call it indices here. If we run it, it runs, and if it's submitted, if 3 to 3, then we do output is 0, 0, but expected is 0. Now let's do this, right? So, I mean, I think there is some problem happening with this checker itself. So what I'll do is I'll put 3 element and then we do 3 to 3. The value is 6. Aha. Okay, yeah, so now I think I'm able to reproduce. So what is the value it's being passed? The value is being passed is, I made a mistake here. Now it's coming proper. I think Leetcode is passing a wrong nums size, perhaps. Right? It could be the case there is a bug in the checker. So is that the reason that this guy did that? Oh man, this would be dangerous. And then I think this guy just did, okay, you are passing wrong num size. So what I'll do is I'll just do like an if else and oh, awesome. So I'll end up doing in that zone. If I see like one more error failing into this works on my machine, you have a shitty checker, Leetcode. Sorry. If, I mean, anyone from Leetcode is watching this. So what did this guy did for nums 3, right? So we have, okay, if nums, this is my case also, nums 2 is 3, you do 0 and 2, and then you return indices. My bad. Index minus 341 out of bounds for zero four three zero. Let's run against my solution. 0430 and then you have 4. Zero, 4, 3, 0, let's just make it 0. It's coming as 0 and 3. Why would line, okay, let's debug this. Line 46 character 24, right? So line 46, this hash map, calculation hash map is creating this problem. Minus 341 out of bounds for type note. Hash map should be, how can a hash map be minus 341? Okay, I am out of words. I don't know how it's being calculated, but I think we tried to change the hash function, right? Last time. Good hash function. Easy. I wrote a bad hash function, probably. York University hash functions. Okay. Integer to integer for int. No, this will work. Pinning mid square method. Okay. So string folding. Integer hash function. What about this? What about this Leetcode? This is hash 32 shift based on original suggestion on Robert Jenkins' part in 1997. I've done research for a version of the integer hash function. This is where it is. Okay. Bitmix function. Let's do some bit mixing. Okay, yeah, there's too many places where we're calling it num. Yeah, keys I think are better than anyway. Okay. Should it be this, right? Probably a typo. So we do bunch of things here. Do we get the right answer eventually? Segmentation fault. No. Yeah. I guess like we are doing that negative thingy here. Probably. Okay, I had to take some break. Looking at some of the hashing functions, I think I'm going into a rabbit hole here. All universities, they have their hash pages, man. Choosing a hash function, multiplication. I think a lot of hash functions are there for string, which makes sense because there are many ways you can do that. Using open addressing. I think we should be specifying int to int hash in C. Integer hashing. But I think we are getting what we can do probably is let's call this a return a less than 0, then minus 1 multiplied by a, then a Still we're getting segmentation fault. Is it because the way I'm thinking is like we're getting percent %d and then some negative number in hash or too large number. We are not able to do that much of bit shifting. What about this? Ensures that hash codes triple. So why isn't this recognized? Is this some like old C syntax which got reverted? Okay, this worked. This worked. God, this worked. So let's just replace this onto Leetcode, changing a hash function with something that worked. H. Should I remove that check for 3 and C? No, can't. Still happens. If I submit, index -4 out of bounds for type. I wish we could debug. Is there any way to debug Leetcode? Integrated debugger in public beta. Okay. No, I think you have to be like premium or something. I don't think I have premium account. I'm a premium user. Or I think I'm a premium user. I didn't know like I'm a premium user. Seems so. Good for me. But why am I not able to see that? Should I just revert to old version, old UI? Run code. Yeah, debugger. Click 9 number. Test case. Okay, awesome. So I think the older UI has the debugger, but the newer UI doesn't have. So, which means Leetcode is breaking. The people who are making Leetcode website, they should do Leetcode more, I think. Now it got accepted. If I submit, okay, still the same error. Run the test case locally. Run code. Okay, so it's reproducible at least. And if I run it, at character 24, line 47, character 24. So here, run code, click line number to add breakpoints. I add breakpoint, right? Okay, debug. Key is 0, hash is 0, map node is this. Continue. Okay, so hash is coming as -4 y. I don't know what this hash function is. So now I think if I can debug it, let's just Yeah, let's actually do it for our previous case, right? Let's change this hash function to what it was before all of this. So this hash function was this simplified hash function. We will just change it to that. We can't change it here. We have to stop the. Okay, got it. And now our test case will be, we will remove that if else block. So this one will remove, and we will run for 336. Run code, compile error in hash code, num is undeclared. Sorry. And run code. Now it's working fine here. And if I put this particular test case under my old hash function, it's coming as 46, right? This one. Go to debugger and maybe put a debug point there. Now we know. Okay, so hash is 47. Hash is minus 341. How can it be? It's just the key, right? So let's put this guy in a variable there. So we'll cut this and call it hash. Something like this. Return hash. Put a breakpoint here, and then we're going to debug it. What is num? Num num is 0 and hash is 47, right? Num is 0, hash is 47. Num is num. What the? Num is minus 4. Where are we calling this hash code function from? Hash code is being called from here, right? So at the time only putting the key only at the time of putting the key, and then I think at the time of getting also we are calling it. And put and get we will only do for is there a subtle bug that's there which we are not getting? Let's see the complete flow, right? Put a breakpoint there and let's debug it again. So num size is 4, target is 0, indices is this, I is undefined, and now we step in, I is 0, step again, okay, I think now we are inside that hash function there. Okay, Yeah, let's just continue. I think it will eventually come to that function. So we have hash as 47 now. Where's the control? Keep on doing that. Oh, this is actually tricky to debug. So let's do this. Continue. It's not actually traversing. So I'm trying to reduce the font a little bit so I can see more things in the screen. I know it's probably small, but this will be helpful for me to debug and see the entire flow. Let's run again. And we see hash is 47, num is 0. Continue. We come in get here. Key is -4. How can key be -4? If we go inside that and we calculate, so obviously hash must be -341. How can, so where is get called? Right, this is only here and maybe here. Target minus num psi. Oh, okay. I think we got our bug there. So Leetcode is actually not wrong. It's we took so much long to get to this bug, but I'm glad that we did. I'm glad that we did. I don't know what was the issue with 3.3 though, because with this particular case, yeah, I get it. We should only do it if, I mean, if num size is greater than target, right? So that doesn't make sense. If num size is less than equals target, then only we should do it. So all this remaining stuff, right? This is essentially like doing if num size is greater than target, then just continue. So instead, we just want to wrap it under this. Now it works. Okay, so 3.3 still remains a problem. Why? The thing is, am I able to see it in local run, the issue? What is happening Leetcode? This is working fine here, this is failing here, which means I need to put that check. Num size is 2, then just, I guess it's better because you don't need to bother run the entire thing. You should only do the return statement. So I think they by default assumed like everyone would initialize their indices like that, and if num size is 2, you just return, no calculation. In this particular case also it should run. 3 to 3 is also creating problem. So probably we should also keep 3 to 3 there. If num size is equal to 2, then we just return indices. I think here this should run, and also for this particular test case it should run. Just to prove my point, what I'll do is I'll just comment this section out, just to prove my point that my logic still works without that, but somehow not according to Leetcode. Submitted. I mean, whoever is actually verifying that there. Once we have this minus negative numbers, then it's also problematic because I think our hashing algorithm will be problematic in that sense. So what we can do potentially is we can keep a negative key, right? The only thing is like problematic is hash. So let's just do some quick hack here. If hash is less than 0, then hash multiplied by -1 else hash. Even in this case, your input 0, 1. Yes, I think for minus, it's not actually a problem of negative hashing. It's actually a problem of, even if it's like a conflicting hashing thing, it should not be a problem, right? So this means like there's a bug in our code again. Um, this is fine, but we want to still keep the original hashing. We are getting two different outputs here. It's expecting 0, 2, but yeah. So what we are doing here, we should not do this, because if negative numbers are also there, we should not probably do that. We run the code and now we get it. Still some issue. Run the code. Works fine here. It's a mixed bag of things. There are like things which works here, doesn't work there. I don't know what's going on here with Leetcode. But let's see. Num's size is equals 4 and num's 0 equals -10 and num's 1 equals 7. This is how that guy should have done. Then we would get the entire test case. I mean, if you do the partial matching, then it's also like more runs for you, right? If they have like partial match with other test cases, then how would you do that? This way you do like complete hard coding. Okay. What did I do here? Sorry, I guess. So nums 2 and nums 3 is 15. Then we should return indices. Oh, okay. Okay. No, yeah. Sorry. It should return this. And that's why that guy sort of combined them into a switch case. But what I can do here, probably I can wrap them into an OR function. times 0 is minus 10. I'll just check this one more time and then I'll just leave. If there is an actual bug in the code, I'm of course willing to fix it. But I should send this video link to Leetcode and tell them to check what is happening there. See, right? I copied your input, run in your local machine on at least the session that you're giving me, and the submitter is actually creating problem. 47 out of the 57 test cases passed. I give up on this. I didn't know like I had to do like that, but I give up. And also I give up on today's video. I don't know if it was like that productive, but we found a good bug. That's actually important. I don't know like this hard coding, so let's remove them. I mean, we are fine if Leetcode doesn't accept a solution. We will live with our uncertainties, but this is actually a good part. Probably we should not do negative hashing here. So that's a learning, and I would sort of end at least this part of this video. Something that I wanted to do is look at UT hash. So it seems like UT hash is available by a lot of these OpenJudge platforms. And should we try some other coding platform, perhaps apart from Leetcode? But Leetcode has good set of problems. Probably they have issues with their checker, but Leetcode test cases. Option to view all test cases. Doesn't seem like that. There are some Cora problem as well. I think it's not that open. That's why they don't have it open that much. But yeah, I think test cases are fine, but it would have been good if we at least see and print something in our debugger here. I don't know, like if I print something here, will it go through? Okay, LC. Will it come in the output though? It actually comes in the std out. So that's something I guess like we can explore. Somehow I see this was not there in the new UI, but anyway. But this is something probably we can explore, std out debugging for this, but I don't want to. I mean, that's a waste of time debugging Leetcode's problem for our case. We want to learn about hashing, right? Not debugging their problems. So, okay, that's all for today. See you in the next video.